Hello dear students, welcome to the 8th lecture of the data analysis and the interpretation. In this lecture, we are going to discuss the different steps regarding the hypothesis testing and what are the different categories of the parametric test, and formulas regarding the Z test, T test, F test, and what a situation for applying this Z test, T test and F test. Okay, and the first, what are the different steps or the procedures regarding the testing of the hypothesis. Okay, one of the first step of the testing of the hypothesis, it's deciding the null and the alternative hypothesis. And the H0 is representing the null hypothesis and H1 is representing the alternative hypothesis. So H1, there is a significant difference between the sample and the population mean, and H0 there is no significant difference between the sample and the population mean. Okay, the first step is deciding the null and the alternative hypothesis, and second step is decide the test. The test is decided based on the question, whether it's Z test, T test, F test, and ANOVA. There's a different category of the test. You just decide the test based on your question. And third step is deciding the level of significance. And we are using the three category of the level of significance. So 1%, 2%, 5% level of significance. Whether appropriate level can be used for the calculation of the problem. And fourth step is one of the important steps for the Z test and T test. Decide the basic critical region. That means one-tailed or two-tailed test. Decide the test is one-tailed or the two-tailed. That's the fourth and the most important steps regarding the Z test and T test. Okay, and after that, obtain the table value. Because Z test, T test can be the single table is used, and F test is separate table can be used. Okay, that's calculating the table value. So it means identify the table values for the problem. And the last step is the deciding the hypothesis accept or reject. That's H0 is accepted, H0 is rejected. Suppose the calculated value is greater than the table value, that is H0 is rejected. That means the null hypothesis is rejected. Otherwise, your H1, H0 is rejected, that means H1 is accepted. Suppose the computed value is less than the table value, that means H0 is accepted. Okay, these are the steps for the procedures, steps or the procedures for the testing of the hypothesis. Okay. And let us discuss the different category of the parametric test. The first category is and before that, there is a one-tailed and the two-tailed. How to decide the one-tailed and two-tailed? Okay, and the one-tailed, two-tailed, suppose the question in the equal or the not equal format, that is most probably two-tailed test. But the H0 is mu1 equal to mu0 and mu1 not equal to mu0, that is the not equal format. Suppose the question equal not equal format decide that is the two-tailed. Suppose the question is in the form of increase, decrease, less than, greater than format, we can decide that is the one-tailed. That is the logic of selecting the one-tailed and two-tailed. It's also not a rule for selecting the one-tailed and two-tailed. So just is mainly applied for the Z test and T test. Z test and T test are the apply here, but a question equal not equal format greater than, decrease, increase, less than format the identifier equal not equal, that's the usual format, that's a two-tailed. Otherwise increase, decrease, less than, greater than, that is the one-tailed test. One-tailed test use here. One-tailed test table values bracket values consider. Two-tailed test bold letters table values select here. Okay, that's the rule for deciding the one-tailed and two-tailed test. Okay, and after the first category test is the Z test. Z test is the most significant test for testing the population mean and sample mean. Okay, and what is the rule for designing the Z test? This is one of the important rule for situation for Z test, when n sample size is more than 30 and the population standard deviation which are known or unknown situation, we can use the Z test. Suppose the sample size is less than 30 but the population standard deviation is known, we can use the Z test. These are the situation for applying the Z test. When sample size is greater than 30, a population standard deviation known or unknown, we can use Z test. When sample size is less than 30 but the population standard deviation is known, we can use Z test. Okay, that is a situation for the Z test. And in Z test, there's two important formulas. One is the formula regarding the test given the population mean. Another one is testing the significant difference between the population. Two situation കാണാൻ സാധിക്കും. One is a test given the population and the significant difference between the population mean. Okay, and here before going to the problem representation അറിഞ്ഞിരിക്കണം. What is a sigma? Sigma is represents standard deviation of population. S is the standard deviation of sample. X bar is the mean of the sample. Mu is the mean of the population. N is the number of observations. These are the representation. Sigma, standard deviation of population. S, standard deviation of sample. X bar, mean of your sample. Mu, mean of the population. N is number of observation. This representation which will number problems to. Okay, and the first situation, test given the population means. നിങ്ങളുടെ ക്വസ്റ്റ്യനിൽ ഒരു പോപ്പുലേഷൻ മീനും ഒരു സാമ്പിൾ മീനും തന്നു. നിങ്ങളുടെ അടുത്ത് ടെസ്റ്റ് സിഗ്നിഫിക്കൻസ് ചെക്ക് ചെയ്യാൻ പറഞ്ഞാൽ യു ക്യാൻ യൂസ് എ ഫസ്റ്റ് ഫോർമുല. X bar minus mu divided by the sigma divided by root n, or X bar minus mu divided by S divided by root n. S is the standard deviation of the sample, sigma is the standard deviation of the population. That's the only change. And in the situation of the degree of freedom covers table value and degree of freedom manam, that is n is always infinity. Z test infinity values മാത്രം കൺസിഡർ ചെയ്യാൻ പാടുള്ളൂ. ടേബിളിലത്തെ ഇൻഫിനിറ്റി വാല്യൂസ് മാത്രം നമ്മൾ സെലക്ട് ചെയ്യുള്ളൂ. ഓക്കെ, ആൻഡ് സെക്കൻഡ് സിറ്റുവേഷൻ ഇസ് എ ടെസ്റ്റ് ഗിവൻ ദ സിഗ്നിഫിക്കൻറ്റ് ഡിഫറൻസ്. അവിടെ നമുക്ക് രണ്ട് സാമ്പിൾ സെറ്റ് വരാം, രണ്ട് സ്റ്റാൻഡേർഡ് ഡീവിയേഷൻസ് വരാം, രണ്ട് നമ്പേഴ്സ് വരാം. And this situation we can use this category of formula, that's x bar 1 minus x bar 2 divided by the root standard deviation of 1 square divided by the n1 plus standard deviation 2 divided by the n2. And here there is a s1 square plus s2 square divided by n1 and 2. That's the only change is here the sample standard deviation, here the population standard deviation. That's the only change. And here there's two set of observations, under set of observations varam 1 and the 2, 1 and the 2. Okay, and here there is a degree of freedom. The degree of freedom is always infinity, n equal to the infinity. Degree of freedom infinity ആയിട്ട് കൺസിഡർ ചെയ്യുക. അപ്പോൾ ടേബിൾ വാല്യൂസ് എടുക്കുമ്പോൾ ലാസ്റ്റ് വരുന്ന വാല്യൂ ഇൻഫിനിറ്റി വാല്യൂസ് മാത്രമേ കൺസിഡർ ചെയ്യാനായിട്ട് പാടുള്ളൂ. ദാറ്റ്സ് എ റൂൾ റിഗാർഡിംഗ് യുവർ ദ Z test. This is a situation for applying the Z test. Okay, and similar t-test. T-test is a brother of the Z test. The same situation, that test given the population and significant difference. And the situation is very important. And situation is when sample size is less than 30 and the population standard deviation is unknown. The situation for applying it is situation on a t-test use here. N is less than 30 and the population standard deviation known, we can use Z test. And the population standard deviation unknown, we can use the t-test. Okay, so that is a rule for the t-test. Okay, this is a very important rule. And similar two category of formula, one is the one sample mean and the population mean, x bar minus mu divided by S divided by root n minus 1. The change is the root n minus 1. That's the first situation. The n minus 1 is the degree of freedom. Okay, and similar second situation, and here there is x bar 1, x bar 2, root n1 s1 square plus n2 s2 square divided by the n1 plus n2 minus 2 into 1 by n1 plus 1 by n2, that is within the root. Okay, so that is a significant difference. And here the degree of freedom is n1 plus n2 minus 2, n1 plus n2 minus 2. അപ്പോൾ ഇവിടെ നമുക്ക് ഡിഗ്രി ഓഫ് ഫ്രീഡം എഴുതുമ്പോൾ ശ്രദ്ധിക്കേണ്ട കാര്യമുണ്ട്. ഡിഗ്രി ഓഫ് ഫ്രീഡം ഇവിടെ ഇൻഫിനിറ്റി വാല്യൂസ് അല്ല, ആ n1 നമ്പേഴ്സ് വെച്ചുള്ള വാല്യൂസ് ആണ് ഇവിടെ കൺസിഡർ ചെയ്യാം. Okay, so this is a very important element. After that, F test. That is a third category of test is F test. F test is mainly used for the checking the model fit. That's the applicability of the F test. And here we are checking the significant differences of the variance and the standard deviation. The testing the equality of the variance or the standard deviation. Variance or standard deviation so check ചെയ്യാൻ വേണ്ടി നമുക്ക് ഏറ്റവും കൂടുതൽ യൂസ് ചെയ്യാൻ പറ്റുന്ന ടെസ്റ്റാണ് ദാറ്റ് ഈസ് യുവർ ദ F ടെസ്റ്റ്. അപ്പോൾ നമുക്ക് പലപ്പോഴും രണ്ട് സെറ്റ് ഓഫ് ഡിസ്ട്രിബ്യൂഷൻ തന്നിട്ടുണ്ടായിരിക്കും, അതിൻ്റെ വേരിയൻസോ സ്റ്റാൻഡേർഡ് ഡീവിയേഷൻസ് നിങ്ങൾക്ക് ചെക്ക് ചെയ്യാനായിട്ട് പറയും. വേരിയൻസും സ്റ്റാൻഡേർഡ് ഡീവിയേഷൻ ചെക്ക് ചെയ്യാൻ പറ്റും. നമുക്ക് ഏറ്റവും കൂടുതൽ യൂസ് ചെയ്യാൻ പറ്റുന്ന ടെസ്റ്റാണ് നമ്മുടെ F test. Okay, so that's mainly for checking the distribution, only the two distribution, രണ്ട് distribution set of ഡാറ്റകൾ വെച്ചുകൊണ്ട് മാത്രമേ ചെയ്യാനായിട്ട് നമുക്ക് സാധിക്കുള്ളൂ. And here the rule is one population variance is greater than the other. One population variance is greater than the other. So that is very important element. Okay, let's see the formulas. And the formula point of view, what is F? F test equal to the variance 1 divided by the variance 2. And how to find out the variance 1? Variance is the representation. Variance 1 means n1 s1 square divided by the n1 minus 1. And variance 2 n2 s2 square divided by the n2 minus 1. Okay, there is a first set of variance, is a second set of variance. That means first set of data and this is second set of the data. Okay, s1 square means the variance of first, s2 square means the variance of the second, n1 is the number of observation of the first group, n2 is the number of observation of the second group. That's the representation, n1 s1 n2 s2 n2. And here the degree of freedom, the very important element is the degree of freedom. The degree of freedom is the n1 minus 1 then n2 minus 1. Suppose n1 is 7 and n2 is 6. 7 minus 1, that is the 6. 6 minus 1, so 5. 7, 5. So നമുക്ക് അങ്ങനെയാണ് ടേബിൾ വാല്യൂ കണ്ടുപിടിക്കേണ്ടത്. So this depends upon the degree of the freedom. And here there is one of the important element is the variance 1 is always greater than the variance 2. മുകളിലത്തെ ഭാഗം, മുകളിൽ വരുന്ന ഭാഗം എപ്പോഴും താഴത്തെ ഭാഗത്തിനേക്കാളും ഗ്രേറ്റർ ദാൻ ആയിരിക്കണം. ഇല്ലെങ്കിൽ അങ്ങനെയാണ് നമ്മൾ ചെക്ക് ചെയ്ത് നോക്കണം. മുകളിലത്തെ ഭാഗം തന്നെയുള്ള വലുത്. സപ്പോസ് ന്യൂമറേറ്റർ ആൻഡ് ഡിനോമിനേറ്റർ, മുകളിലത്തെ ഭാഗം എപ്പോഴും ഗ്രേറ്റർ ദാൻ ആയിരിക്കണം. ഇല്ലെങ്കിൽ അങ്ങനെ ആക്കിയിട്ട് വേണം നമ്മൾ പ്രോബ്ലംസ് ചെയ്യാൻ. ദാറ്റ്സ് എ വെരി ഇമ്പോർട്ടൻറ്റ് കണ്ടീഷൻസ് റിഗാർഡിംഗ് യുവർ F test. Okay, and here another important element is how to find out the variance. How to find out the variance? The variance can be find out. That's the formula is a sigma x square divided by the n minus sigma x by n all square. That's the formula for calculating the variance. And variance can be easily calculated. Another formula sigma x minus x bar square divided by the n. X minus x bar square means the sum of the square deviation from the mean. This means ഇതിന്റെ അർത്ഥം sum of the square deviation from the mean ആണ്. Okay, so that is the logic of the variance. Okay, so once again, the first we discuss the steps for the testing of the hypothesis, and basically 6 steps for the testing of the hypothesis. The first important step is decide the null and the alternative hypothesis, and second step is decide the test, whether it's Z test, T test and the F test, and third step is determine the level of significance. The level of significance means normally we are using the 1%, 2% and the 5% level of significance. Okay, and after that determine the critical region, that means for the one tailed and the two tailed test. Okay, and after that the obtaining the table value, and Z test, T test we use in the same table, and F test we are using separate table. Okay, that's a determine the table value, that means identify the table value. And step 6 is another important element, and here we take the decision, accept or reject the hypothesis. Suppose calculated value is greater than or the computed value is greater than the table value, that means rejecting the H0, and computer value is less than the table value, that means we are accepting the null hypothesis. That is a rule for or procedure for the testing of the hypothesis. And another important element is the rule, very important element is how to decide the one tail and two tail. Suppose the question is the equal or the not equal format, we can use the two tail test. And two tail test, the table values point of view, the bold letters, suppose നമ്മുടെ ടേബിൾ എടുത്തു കഴിഞ്ഞാൽ ബോൾഡ് ലെറ്റേഴ്സിൽ കാണുന്നതായിരിക്കും അതിൻ്റെ ടു ടൈൽഡ്, ബ്രാക്കറ്റ് ലെറ്റേഴ്സിൽ കാണുന്നതായിരിക്കും അതിൻ്റെ വൺ ടൈൽഡ് വാല്യൂസ്. ടേബിൾ നോക്കി തന്നെ കാണാൻ സാധിക്കും. ഓക്കെ, and suppose the question is greater than, decrease, increase, less than format, we can use the one tail test. That's the logic of selecting the one tailed and the two tailed test. And after that the Z test, and Z test three important condition is when Z test apply three important condition പറഞ്ഞത് നമ്മൾ suppose the sample size is greater than 30 and the population standard deviation is known or unknown deviation, we can use Z test. And n is less than 30, the population standard deviation is known or given in the situation, we can use Z test. And Z test found with two important formula. One is the given population, another one is a significant difference. That means two sample groups. The first situation, and these are the formula, x bar minus mu divided by the standard deviation root n, and the degree of freedom is very important, is n is infinity. And second situation, significant difference, and there is a x bar 1 and the x bar 2, and the change is there is a 2 standard deviation and 2 sample mean, and the degree of freedom is always infinity. And what is the representation? N is standard deviation of population, S is standard deviation of sample, x bar is the mean of sample, mu is the mean of population, n is number of observation. These are the representation. Representation നോക്കിക്കഴിഞ്ഞാൽ അപ്പോൾ നമുക്ക് ടെസ്റ്റ് ഡിസൈഡ് ചെയ്യാൻ പറ്റും. റെപ്രസെൻറ്റേഷൻ ചെയ്ത് തന്നെ നമുക്ക് ടെസ്റ്റിലേക്ക് കടക്കാനായിട്ട് സാധിക്കും. And this is the t-test. A t-test is a situation when n is less than 30 and the population standard deviation is unknown. We can use the t-test. In this situation, we can use the t-test. And the t-test similarly is two situations. One is a test given the population and the significant difference between the population. So as a test given the population, the formula is x bar minus mu divided by the s divided by root n minus 1. But here the degree of freedom is n minus 1. This is very important element, is the degree of freedom n minus 1. And significant difference, this is the formula for the significant difference, and there is the degree of freedom, very important, n1 plus n2 minus 2. And finally you are the f test. This is an f test. Okay, and this test is mainly for checking the standard deviations and the variance. And this is a formula for f test, and this is the representation, and this is the degree of freedom of the f test, and this is a formula regarding the variance. Okay, thank you so much, and thank you for watching me.